we have a large right triangle, ABC. The 90-degree angle is at point B. And along the hypotenuse, AC, there's a point Q placed exactly in the middle. That means AQ equals QC. Let's call both of those lengths A. Now, from point Q, a vertical segment rises upward and hits the top side at point P. And this segment, PQ, is perpendicular to the hypotenuse AC. Now here are the two critical clues about the small triangle on the left, triangle AQP. Its hypotenuse, AP, is 13, and its area is exactly 26. Our goal is to find the remaining top segment, PB. We'll call that length X. Let's begin with the area information. Triangle AQP is a right triangle. Its base is A. Let's call its height PQ. Why? Using the area formula, base times height divided by 2 equals 26. So, A times Y over 2 equals 26. Multiply both sides by 2, and we get A times Y equals 52. That equation is going to become very important later. Now let's look at the angles. Call the angle at A alpha. Since the large triangle ABC is a right triangle, the angle at C must be 90 degrees minus alpha. Let's call that angle beta. Now focus on the small triangle, AQP. It already has a 90-degree angle at Q, and it shares angle alpha at A. So the remaining angle at P must also be beta. Which means the small triangle and the large triangle have exactly the same 3 angles. So the triangles are similar. And once triangles are similar, the side ratios line up beautifully. The hypotenuse of the large triangle is the entire base AC. But AC is made of 2 equal pieces, A plus A. So the hypotenuse is 2A. The hypotenuse of the small triangle is 13. Now let's compare the sides opposite angle alpha. In the large triangle, that side is BC. Let's call it B. In the small triangle, the matching side is Y. So we can write 2A over 13 equals B over Y. Cross multiply. 2AY equals 13B. But wait, we already know that AY equals 52. So substitute that in. 2 times 52 equals 13B. That gives us 104 equals 13B. Divide by 13, and suddenly B equals 8. So the entire right side BC is exactly 8 units long. Now we're very close. Let's draw one extra segment connecting P to C. Now look at the two triangles resting on the hypotenuse. Triangle AQP and triangle CQP. Both have a base of length A, a shared height Y, and a right angle at Q. They are congruent, which means their hypotenuses must also be equal. Since AP is 13, CP must also be 13. Now, focus on the small triangle in the upper right corner. Triangle PBC. It's a right triangle. Its vertical side, BC, is 8. Its hypotenuse, PC, is 13. And the remaining side, PB, is our mystery X. Time for the Pythagorean theorem one last time. X squared plus 8 squared equals 13 squared. So, x squared plus 64 equals 169. Subtract 64. X squared equals 105. Take the square root, and we get x equals square root of 105, which is approximately 10.25. Such a satisfying finish. This problem uses almost everything. Area formulas, similar triangles, congruent triangles, and finally, the Pythagorean theorem. Did you expect the answer to involve square root 105? Let me know, and I'll see you in the next one.